Question 8a. So it says the surface of oceans are curved. Although we tend to think about water forming large flat sheets, the surface of a large body of water is actually not flat at all. It follows the curvature of the earth, obviously, which is circular then. So the diagram below represents part of a circular cross-section of the earth from a point A on top of a mountain, 4.83 kilometres above sea level. An observer measures the angle of depression. So this angle here is your angle of depression. So, because that's your viewpoint, and your depression means to go down 2.23 degrees. Now, this is ridiculous if they think that's nearly off-putting, but it is a mock paper, I suppose, just to keep in mind. But that's 2.23 degrees. Find AHO, this angle here, and give a reason for your answer. Well, we're looking at the fact that straight line here, and it seems to be just hitting off the curvature here, a tangent to it, and if I have a tangent, I have 90 degrees. So you can just say it's 90 degrees, and any of your normal reason tangent is to a circle is perpendicular to the radius of the circle that goes to that point of contact, or just tangent to a circle is 90 degrees to the radius at that point. Part 2 of A, it says, hence use a suitable trigonometric ratio to show that, correct the nearest kilometre, the radius is 373 kilometres. So I'm going to use my right angle triangle here. I can use this information. I have 90 minus the 2.23, and I end up with 87.77 degrees here. And if I use, what am I looking for? They want me to find the radius of the earth. So I'm going to use these two here. I have 2 bits of information missing, but they're the same thing. Now, the radius is to here, so I'm going to have to add on the 4.83 for the length from A to H. So we have this, which is the opposite, and this is the hypotenuse, so we're looking at sine. So for part 2, the sine of 87.77 degrees is equal to opposite all over hypotenuse, which is the radius plus the 4.83. Sorry, 4.83. So sine of 87.77, I might as well save this, I'd say. Sine of 87.77 is that. I'm just going to store it in there. And that's 0.9992426,796 is equal to R all over R plus 4.83. Going to bring this over, it becomes multiply. So it's the 0.999 ... multiplied by R plus 4.83 is equal to R. And I'm going to have to multiply this out here. So that's 0.999. Now, I'm not rounding off here at all, times R. Plus 0.99999 times 4.83, which I'm actually just going to store as well as B. That's equal to R. So I'm going to bring this over. 4.826 ... I have it stored, is equal to R minus the 0.999 ... times R. I'm going to take the R out in common. I have 4.826 ... is equal to R is coming out in common, 1 minus 0.999 ... I'm going to get the answer to that. So it's in my calculator, it's been stored as A, so it's 1 minus A, okay, which is R times, I'm just going to store that as C, 0.000753 ... It's stored anyway in my calculator, so 4.826. I'll just write down, maybe you may want to write down that's stored as B, that's stored as C in my calculator, and back up here that was stored as A. So now I need to bring this over, it becomes division, so it's B divided by C leaves me with 6,372.919971 is equal to R, and that's, when I round it off, 6,373 kilometres, which is what they wanted at the start. Okay, part B then, it says, in astronomy, the same concept can be used to determine the distance between the Earth and objects in space. So they have a little diagram here for me again. Looks quite similar to what I've already been looking at, just maybe from a different perspective. Or here we have S, O, E. This is my radius. That's also my radius as far as there. And then the rest of the distance from this point here, they say is D. So it says let O be the centre of the Earth this time, so we're looking at the distance between the Earth and objects in space. So S can be whatever object in space I want. S is, it says actually represent the nearest point of the object in space. So whatever the object is, this is going to represent the nearest point to it. Is S. Given that the Earth is positioned in such a way that OES is 90 degrees, in the case of the Sun, it has been found that this angle here, they've called it alpha, is 0.00244 degrees. And using the result from part A above or otherwise, find correct nearest kilometre, the minimum distance between the surface of the Earth and the surface of the Sun. Well, there's the surface of the Earth and the surface of the Sun. There's the minimum distance between them. That's the shortest distance. So we need to find this. And this is a right angle here. I know that this is R and this is R plus. Now, they said to use the information from the previous question. So O to E is the radius of the Earth, which we just found out is 6,373. So in this situation, I know this is 6,373 and this is 6,373. So if we look at here again, we're looking at sine because that's opposite. That's the hypotenuse and that's the side that we care about. Then sine of 0.00244 degrees is equal to OE, the length of O to E over O to S. I can work that out. We're on a different sum here, so I might just store this. The sine of 0.00244. Okay, and I'm going to store that as A. I'm just going to write that down there, that I'm going to store it as A. OE is, so that's the sine of that, is equal to 6,373 all over the length of OS, which is what we're looking for. So I'm going to bring this over, it becomes multiply OS times the sine of 0.00244 degrees is equal to 6,373. OS is equal to 6,373 divided by the sine of 0.00244 degrees. So this is stored as alpha in my calculator now, so I have the 6373 divided by alpha, and I have that the length of OS is equal to 149650001.2. Now, that's the length of OS. I don't want all of O to S. I'm actually looking for the fact that I want to find, correct, the nearest kilometre, the minimum distance between the surface of the Earth, so from there to the surface of the Sun. So I'm only looking at this part here, so I need to subtract from this my 6373. And I have 149,643,628.2, but they want the nearest kilometre. So that's my answer there.